Hey everyone, and welcome. So you want to learn Alen Bradely PLC programming, right? But you've probably hit the same wall everyone else does, the hardware. I mean, a real controller and all the modules can get seriously expensive. But what if I told you that you don't need any of it to get started? In this explainer, I'm going to show you exactly how.
It's a classic catch-22, isn't it? You need experience on the hardware to get a job, but you need the job to get your hands on the hardware in the first place. So how in the world do you break that cycle and start writing real, honest-to-goodness ladder logic like today?
Well, the answer is simulation. We are going to build a complete, fully functional Alen Bradely PLC rig right here on your computer. And the best part, we're using free-to-download software from Rockwell Automation. That means no hardware, no cost, just pure, unadulterated learning.
Okay, so to pull this off, you're going to need a very specific set of tools. This entire virtual setup hinges on 3 key pieces of software that are designed to work together, creating a totally seamless environment right on your desktop.
And here they are, our 3 musketeers. You got Logix Emulate, RS Linx Classic, and Studio 5000 Logix Designer. Think of them as the brain, the nervous system, and the workbench of our virtual machine. Let's break down what each one actually does.
First up is Logix Emulate. Now this is really the magic piece of the puzzle. It creates a virtual chassis on your computer where you can pop in a virtual CPU and virtual I/O modules, just like you would in a real-world control panel. It's the digital brain that's going to run all our code.
Next, we've got RS Linx Classic. You can think of this as the universal translator or the communications hub. Its entire job is to build a bridge so your programming software can talk to your virtual PLC. Without RS Linx, they wouldn't even know the other exists. It is the absolute critical link in this whole chain. And finally, Studio 5000 Logix Designer. This is your command center. This is the actual software where you'll be writing your ladder logic, creating your tags, and managing your entire project. This is where all the engineering really happens.
All right, now that we know what the tools are, let's get our hands dirty. In this section, we're going to walk through the exact steps to get these 3 programs configured and talking to each other like they're old friends.
It's a pretty straightforward 3-step process. First, we'll build the virtual hardware and emulate. Then, we'll create the communication driver in RS Linx. And finally, we'll set up our programming project in Studio 5000 to match everything perfectly. So, let's dive into step 1.
Okay, so when you open up Logix Emulate, you'll see this empty virtual chassis. We're going to start by adding our main components. In slot 2, we'll create our virtual controller. That's the CPU. Then, right next to it in slot 3, we'll add a virtual input-output module. And believe it or not, with just those 2 clicks, our virtual hardware is pretty much built.
Okay, listen up, because this is the single most important rule in this entire process. Your software versions have to match. I can't stress this enough. If your Studio 5000 software is, say, version 30, you absolutely must create a version 30 virtual controller in Emulate. If they don't match, they just can't talk to each other, and none of this will work. So always, always check your versions.
So, with our virtual PLC up and running, we just hop over to RS Linx Classic. In here, you're going to configure a new driver. The one you're looking for is called the Virtual Backplane Driver. As soon as you add it, it'll automatically scan your computer and bam! It'll discover that virtual controller you just made. You should see your CPU in slot 2 pop light up.
Now for the final setup piece in Studio 5000. When you create a new project here, you have to be really precise. You'll need to select the Logix Emulate controller type, make absolutely sure the version matches, in our case V30, and tell it that it's in slot 2. Then, you'll add a new module to the project's I/O tree to represent that card we put in slot 3. Everything has to mirror your virtual rig perfectly.
And here we go. This is the moment we've been working towards. The rig is built, the communication is solid. Now it's time to actually write some code, download it to our virtual PLC, and watch it run.
You know, this first download is the ultimate test of our entire setup. Even if the program is completely blank, this will tell us if all the pieces are communicating correctly. We're just going to go to the Communications menu, find our virtual CPU, and hit download. This is the moment of truth.
And success! Once the program downloads and you switch the controller into run mode, you should see this fantastic little green indicator light up. I/O-OK. This is exactly what we wanted to see. It means Studio 5000 is talking to the I/O module through the CPU, all virtually. Our entire system is officially online.
Now, before we write our first line of code, let's do a quick primer on tags. In Studio 5000, tags are just names for your data. Think of them like variables.
Controller tags are global, they're public. You'd use them for stuff that an HMI screen or another system needs to see. Program tags are local or private, used only inside that one specific program. For our little test, we'll go ahead and create some controller tags.
Okay, let's build our very first program. It's going to be super simple. We'll create 2 tags, one for a virtual input, one for a virtual output, and we'll link them to our I/O module. Then we'll write one single line of logic. If the input is on, then turn the output on. After we download the changes, it's time for the fun part.
And this is the magic moment, the payoff for all that setup. Right inside Studio 5000, while you're online with the emulator, you can actually right-click your input tag and just toggle the bit from a 0 to a 1. The instant you do that, you'll see the logic go green and your output bit will immediately fire on. You've just run your first PLC program on a completely virtual rig. How cool is that?
So let's just recap the awesome toolkit you've just put together. You have Logix Emulate acting as your virtual hardware, your PLC. You have RSLinx Classic, which is that all-important communication bridge, and you have Studio 5000 as your programming workbench. Together, these 3 create an incredibly powerful, hardware-free learning environment.
So you now have everything you need to practice, to experiment, and to learn Alen Bradely programming without spending a single dime on physical hardware. You can simulate complex machines, you can test out timers and counters, you can build entire projects from scratch. The barrier to entry? It's gone. So the only question left is, what are you going to build first?
Like, share, and subscribe for appreciation and more content.